Hello everyone. In this video, I am going to explain how to solve the first order ordinary differential equation. We know what is the differential equation and the types of the differential equation, which is ordinary differential equation and partial differential equation. Here, we are going to explain ordinary differential equations. Differential equation of first order and first degree. What is the order of the differential equation? That is, the highest derivative in the differential equation is nothing but the order of the differential equation, and the power of the highest derivative is nothing but degree of the differential equation. So now coming to the general form of the first order and first degree differential equation, an equation is of the form dy by dx equals to f of x comma y is called the differential equation of first order and first degree. So to solve the first order and first degree differential equation, there are some different methods. So variable separable, homogeneous equation and reducible to homogeneous form. And third one, exact differential equation and those which can be reducible to exact by some integrating factors, and linear differential equation and Bernoulli's equation. So by using these, we can solve the first order ordinary differential equation. That means we are going to find the solution of the differential equation. And what is the solution of the differential equation and particular solution, what is general solution, I will give detailed in notes, which will be added in the link. So now before going to learn the ordinary differential equations, first as a student you have to know what are the applications of differential equations, where we are applying this topic in BTech. So as a computer student, you have to know that computer science is not only coding, it is about modeling systems that change with the time. So and first order ordinary differential equation describes rate of change. So I'm giving some applications. First one is machine learning gradient descent. This is one of the most application part using differential equation. Suppose if you want to minimize any loss function, we use the condition dw by dt equals to minus nu into dl by dw. So w is the weight and t is the time. So whenever we want to minimize or decreasing the loss function, so then we use this condition. So here we used in neural networks, deep learning and AI optimization. So coming to the real platforms, Google, OpenAI and Meta. So next one application is control systems in robotics, used in self-driving systems, drone stability, robotics, example Tesla, Boston Dynamics. And third one application is game development. Physics engines use dv by dt equals to a. So used in character motion, real-time animation. So we use differential equations in game development also. Cloud computing and load balancing. Server load changes over time. So dl by dt equals to incoming traffic minus processing rate. So here we use the differential equations. So real time Amazon Web Services. Next, next application is data science and exponential growth and decay. dv by dt equals to ky, used in viral content spread, user growth predictions, population modeling. Example growth models used by Instagram and YouTube. So whenever something updates continuously, that is weights in AI, network traffic, population of users, mathematics behind is a differential equation. So coding is implementation, just differential equation is modeling. Suppose I just explain one more thing. Suppose you design a social media platform. How will users grow? That growth is exponential model. That means again differential equation. When you simulate a game character movement, again rate of change. So these are the applications of differential equations in the coding. So now coming to the here I told you these are the methods to solve the differential equations, right? So variable separable method you already learned in intermediate. Homogeneous equations and reducible to homogeneous also you learned in intermediate. In BTech the syllabus starts with exact differential equation and those which can be reducible to exact differential equations by some integrating factors. So now in this video I am going to start the exact differential equations. So what is exact differential equation? Suppose let m dx plus, if the differential equation is of the form m dx plus n dy equals to 0, then it is a first order and first degree differential equation first of all, and that differential equation is of the form m dx plus n dy equals to 0, where m comma capital N are real valued functions, real valued continuous functions of x comma y. Then the equation m dx plus n dy equals to 0 is said to be the exact differential equation if there exists a function f of x comma y such that dou f by dou x equals to capital M and dou f by dou y equals to capital N. Like that. See, dou f by dou x equals to capital M, dou f by dou y equals to capital N. Like that, some function should exist which is f of x comma y. Then we can say that m dx plus n dy equals to 0 is called an exact differential equation. This is for the examination purpose only. But when you are solving the problem, we need to verify one condition, that is dou m by dou y equals to dou n by dou x. The condition of the exact differential equation is dou m by dou y equals to dou n by dou x. If dou m by dou y equals to dou n by dou x, then we can say that given differential equation is exact differential equation, and then we can find the general solution. What is the general solution of the exact differential equation is integral m dx plus integral n dy equals to c. Here integral m dx, y should be constant in this term, plus integral n dy. Here in this term, without x terms only, we consider and integrate it with respect to y equals to c is the general solution. Okay, now solve the differential equation. Coming to the problems, solve the differential equation. 2x minus y plus 1 into dx plus 2y minus x minus 1 into dy equals to 0. We have to solve. In the examination they don't mention this is solved by using exact method, solved by using if it is linear equation solve this, now it is Bernoulli's. They don't mention method names. You have to identify this is in exact form, this is linear form, this is Bernoulli's form, then by using that method you have to solve it. Okay, now see, by seeing the problem, you understand that the given equation is of the form m dx plus n dy equals to 0. So here m equals to, what is m? What is m? M equals to 2x plus 2x minus y plus 1 and n equals to 2y minus x minus 1. Now you have to check the condition which is dou m by dou y and dou n by dou x. M differentiating with respect to y partially, because here the term contains two variables x and y. Okay, so we have to differentiate with respect to y only. So dou by dou y of 2x minus y plus 1. So you know partial derivative with respect to y means other variable treating as constant. So 2x constant 0 minus y derivative minus 1 plus 1 constant 0. So dou m by dou y equals to minus 1. Now dou n by dou x, differentiate n with respect to x partially. So other than x, treat it as constant. So dou by dou x of 2y minus x minus 1. So with respect to x, y derivative 0, x derivative 1, so constant 1, derivative 0. So answer is minus 1. So now dou m by dou y equals to dou n by dou x. So the given differential equation is an exact differential equation. Now given differential, we conclude that the given differential equation is exact. Now we have to find the general solution. Now see, every time I'm saying the general solution and general solution. What is general solution? General solution means a solution contains the number of, see, finally after finding that I am saying that this is the general solution, right? So the solution, general solution means the number of in arbitrary constants. Solution contains number of arbitrary constants which is equal to the order of the differential equation. See how many arbitrary constants are there here? Only one. So that number of arbitrary constants is nothing but the number of order of the differential equation. So what is the order of the differential equation? Here we are using first order differential equation. So that number of arbitrary constants involved in the solution. Okay. So and the relation between dependent and independent variable with arbitrary constant, that is the general solution. Okay, so here x square plus y square minus xy. So relation between dependent and independent variable. So x, y are dependent and independent variable with arbitrary number of arbitrary constants. So that is the general solution. So now coming to the general solution of exact formula, I told you already, integral m dx plus integral n dy equals to c. Whenever you are writing the general solution, you have to compulsory you have to write this one y constant for the m integration. For the n integration, you have to write without x terms. So here I am going to integrate m with respect to x. Here y should be treating as constant and n. Integrate n with respect to y. Here you have to consider without x terms. That means without x term only you should consider as n and differentiate it with respect to, integrate with respect to y equals to c. Now see, integral. What is m? 2x minus y plus 1. Y constant into dx plus integral n. First you write n as it is. X terms you cross out and remaining terms you integrate with respect to dy. So what is n? 2y minus x minus 1 into dy equals to c. In this is one term, this is one term, this is one term. In the 2y there is no x, so we should consider. Here x is there, so we should not consider, you cross out. Minus 1 there is no x term, so you have to consider it. Now integrate this m dx, m. So 2x integration 2x square, x integration x square by 2 minus y should be constant here, right? So y is constant, you take outside, integral of 1 dx is x plus integral 1 dx is x plus. Here only without x terms you should integrate with respect to 2y. So 2y square by 2 minus y equals to c. You simplify it, x square minus yx plus y square minus y equals to c is the general solution, where c is the arbitrary constant. So solution of the differential equation is nothing but a relation between the dependent and independent variable not containing their derivatives. See, this is the differential equation. We are eliminating the derivatives. Dy by dx term we are eliminating. We are eliminating the derivatives and finally just we are finding the answer, which is the relation between dependent and independent variable with arbitrary constant. So that number of arbitrary constants are nothing but the number of order of the differential equation. So that is the general solution. I hope everyone understood this problem and go for the next one, which is second problem. Solve y square minus 2xy into dx that equals to x square minus 2xy into dy. See here, the problem is not directly into mdx plus ndy form. Mdx plus should be there, but equals to is there. So make it into mdx plus ndy. Y square minus 2xy into dx minus, if you move the term into left side, minus of x square minus 2xy into dy equals to 0. Still it has minus there, so make it into plus. How can you make it as plus? Take minus outside. Y square minus 2xy into dx. If you take minus common, we'll get plus 2xy minus x square into dy equals to 0. Now this equation is of the form m dx plus n dy equals to 0. Now where m equals to, see how can you take m, dx coefficient is as m, dy coefficient is as n. So like that you have to compare it. So dx, dx coefficient is m. So m equals to y square minus 2xy and dy coefficient is 2xy minus x square. So that you have to consider it as n. So 2xy minus x square. Now differentiate m with respect to y. Dou m by dou y equals to dou by dou y of y square minus 2xy. So this equals to y square derivative 2y minus 2x. Okay, y derivative 1, 2x is constant, minus 2x. Next, in the same way, find dou n by dou x. Differentiate n with respect to x. So, the derivative of x is 1. So, 2y is constant, x square derivative is 2x. So, now observe this, dou m by dou y equals to 2y minus 2x and dou n by dou x equals to 2y minus 2x. So, therefore, clearly we get it, dou m by dou y equals to dou n by dou x. Hence, the given differential equation is an exact. Given differential equation is an exact differential equation. Okay. So, now after concluding the exact given differential equation is exact, now we have to find the general solution, right? So what is the general solution? So general solution, first every time you have to write the formula integral m dx plus integral n dy equals to c. Here y constant and n for n without x terms. Without x terms. That implies integral, what is m? Y square minus 2xy into dx plus integral 2xy minus x square into dy equals to c. Y constant here, so without x terms here. So after writing n, x term you crossed out. Okay, both the terms crossed out. So we get integral y square minus 2xy into dx, y constant plus integral 0 that equals to c. So now y square integral of 1 means x minus 2y integral of x means x square by 2 equals to c. So answer 2 get cancelled. Answer is y square x minus yx square equals to c is the general solution where c is the arbitrary constant. Okay. Now third problem. See here I am explaining different problems. So you can download my PDF. So many problems are there. You can follow it. Solve next problem. Solve e power y plus 1 into cos x dx plus e power y into sin x dy equals to 0. So dx, now the given differential equation is of the form directly it is in the form of m dx plus n dy equals to 0. So here m means dx coefficient. So what is m here? E power y plus 1 into cos x. Next here n equals to, what is n? Dy coefficient, e power y into sin x. Now find dou m by dou y. Differentiate m with respect to y partially. So cos x is constant, only e power y plus 1 you can differentiate. E power y derivative is e power y plus 1 derivative is 0. Okay, so e power y cos x is dou m by dou y. Next, similarly, dou n by dou x. Now differentiating n with respect to x. So e power y term is constant, sin x derivative is cos x, e power y cos x. Now see, Clearly dou m by dou y equals to dou n by dou x. Dou m by dou y equals to dou n by dou x. Hence given differential equation is an exact differential equation. Now we find the general solution. The general solution is integral m dx plus integral n dy equals to c. Y constant here and here without x terms. So integral, what is m here? E power y plus 1 into cos x dx plus integral e power y sin x into dy equals to c. Here y constant without x term. E power y into sin x is a single term. Terms are separated by plus or minus only. So e power y into sin x is a single term. Here x is there, so you crossed out. Don't consider this term. So e power y plus 1 is a constant here. Integral of cos x into dx equals to c. So e power y plus 1 into integral of cos x means sin x equals to c. So e power y plus 1 into sin x equals to c is the general solution, where c is the arbitrary constant. Okay, I hope everyone understood that problem. Next problem, you can see y into 1 plus 1 by x plus cos y into dx plus x plus log mod x minus x sin y into dy equals to 0. Here what is m? Dx coefficient. See, the given problem is directly in the form of m dx plus n dy equals to 0. Here m equals to y into 1 plus 1 by x plus cos y. Now find dou m by dou y. 1 plus 1 by x is constant, the derivative of y is 1, plus cos y derivative is minus sin y. So simplify this, you write it clearly, 1 plus 1 by x minus sin y is dou m by dou y. Next n, what is the n value? The coefficient of dy is n. So x plus log mod x minus x sin y is the n. Now differentiate n with respect to x partially. So with respect to x, x derivative is 1 plus log mod x derivative, log x derivative is 1 by x minus sin y is constant, x derivative is 1. So 1 plus 1 by x minus sin y. Now see dou m by dou y and dou n by dou x, both the values are same. Hence therefore dou m by dou y equals to dou n by dou x. So given differential equation is an exact differential equation. Now we find the general solution. The general solution is integral m dx plus integral n dy equals to c. Here y constant without x term. Examination, when you are write the formula, you have to write this suffix values, y constant without x terms definitely. So here integral m, what is m? Y into 1 plus 1 by x plus cos y into dx. So y constant here plus here integral x plus log mod x minus x sin y into dx into dy equals to c without x terms. See here, this is x term, no consider, this is x term, no consider, this is also x there. So all the terms get be cancelled. So no term which has no x, no term is there which is only y. So that implies, now with y constant here integrating with respect to x. So y integral of 1 means x plus 1 by x. The integral of 1 by x is log mod x plus here cos y is constant. Integral of 1 into dx means x equals to c. So just rewrite again, xy plus y log mod x plus x cos y equals to c. Okay, here this is y is common for both the terms, 1 plus 1 by x. So 1 plus 1 by x, after integration you will get x plus log mod x. Cos y is constant and integral of 1 dx is x here equals to c. So after simplification we get xy plus y log mod x plus x cos y equals to c is the general solution. Where is the general solution? Where c is the arbitrary constant. Okay, I hope everyone understood all these problems. If you want more problems, you I'm in the description you see my the link of the PDF. You can download my PDF and go through all the problems. If you have any doubt, you just put a message. Thank you.